Hello, my name is Jakub Staroń and welcome on the next MedChem Essentials seminar. Today we continue talking about volume of distribution. This is the part of the second large block of our course related to half-life. Today we'll start with the introduction of the term of volume of distribution at steady state, then we'll move into the discussion of how nature of the drugs affect volume of distribution, in particular basic, neutral, and acidic drugs. So, volume of distribution at steady state is related to a situation where you have a constant concentration of the drug. This happens when a patient is taking pills or injections at regular intervals of time, which maintains concentration of the drug at the constant level. Volume of distribution is one of the most important pharmacokinetic property of the drug candidate. It is usually determined following the intravenous administration, just to exclude all the complexity caused by absorption and the first pass effect. It is the most important property because it appears to be the major determinant of half-life and dosing frequency. You may recall situation when we were talking about fraction unbound. In case when the fraction unbound of the drug was low and majority of the drug was being bound to tissues or plasma proteins, the clearance of the drug was lower because the concentration of the drug, free drug, available for metabolism and exclusion from the system was lower. This is affecting, and because of that, the half-life will be higher, and this is affecting dosing frequency, also lowering the dosing frequency because as the drug being will be gradually released from this reservoir, which will be the plasma proteins or the peripheral tissues, recovering the therapeutic concentration of the drug in plasma. For similar lipophilicity, the ionization state of the drug will be the most important parameter that will affect volume of distribution. So for basic drugs, we'll see the highest volume of distribution, and for acidic drugs, the lowest volume of distribution. Let's move to the exact examples. We have 6 drugs: indomethacin, ketoprofen, fluconazole, diazepam, chlorpheniramine, and fluoxetine. For all of these drugs, we have pKa, we have log P, log D, we have fractional bound in plasma and volume of distribution. So, and most neutral and basic drugs, they bind to tissue constituents, so they have low fractional bound in tissue. This is different from fractional bound in plasma. This is more difficult to measure because it's just hard to take a sample of let's say muscle or like liver and just homogenize it and measure concentration than just taking a portion of the blood. Let's talk about the basic compounds. Basic compounds, they have high volume of distribution because they will be highly bound to tissues, because tissues are rich in acidic phosphatidylserine. Mostly this happens for lungs, then kidneys, liver, muscle, and heart, and the brain. As you may recall, back in the past, when we were talking about the cellular context of permeability, that when we were describing the chemical composition of the membrane, that these acidic phosphatidylserines, they constitute membranes of these peripheral tissues, thus affecting to a very high extent how the drug behaves in the body. So the bases will be drawn from the systemic circulation and will be accumulated by electrostatic attraction to phospholipids in the peripheral tissues. As a consequence, they will have a high volume of distribution between 1 and 25 liters per kilogram. So you can imagine for an average human, and this can go up to hundreds of liters. Moving on to neutral molecules, here the extent of this membrane tissue binding will be governed mainly by log D or log P, because it's equal for them. They don't have ionization state. In this case, Diazepam with higher log P will have already, you can see it has the higher volume of distribution. So the volume of distribution for neutral drugs usually will be placed between 0.7 and 4 liters per kilogram. Moving on to acidic drugs, they have very high affinity for lysine-rich albumin. Also, you may recall from when we were talking about fraction unbound that albumin is the main constituent of plasma proteins, about 55% of the whole mass of proteins. And this is reflected by particularly low fraction of unbound of these drugs. So the volume of distribution in general will be quite low, between 0.1 and 0.4 liters per kilogram. This again poses another challenge for drug design and development, and as these drugs will be contained almost only to plasma, which will be affecting all their pharmacokinetic properties to a different extent than for basic drugs. And on this last chart, we have plotted different drugs against their clearance and volume of distribution. Both are logarithmic equations, logarithmic plots. So acidic drugs are represented by black circle, basic by red circle, and proteins by black triangles. Along the diagonals on this logarithmic plot, we have half-lives of these drugs. So along this diagonal, or drugs placed along this diagonal will have 100 hours half-life. We'll be talking in detail about half-life on the next episode seminar. Also of particular of note is that drugs of very low clearance and high volume of distribution, they are very uncommon, because just having a drug with 10,000 hours half-life is completely impractical for drug therapy. This would need to be very, very specific case, but it is rather impractical. Also of note is that large proteins, represented by these black triangles, they have a volume of distribution very close to the plasma volume, which is of 3 liters. So they will be not only not bound to albumins, not bound to tissues, but just dissolved in the plasma, and nicely reflected with what we were talking before. Basic drugs, they have larger volumes of distribution than acids. When it comes to clearance is very strongly affected by the chemical structure of the drug, how prone it is to metabolism. So we cannot say we cannot establish here a direct simple correlation between volume of distribution and the clearance, because there are many other factors influencing this case. Thank you very much. That's all for today, and see you next time. Bye bye.